Thank you, students. I am very much happy to present this small piece of work called Lamis theorem. I am going to prove that now the Lamis theorem. This is coming in statistics, but very much useful in the practical field. I mean, in physics and engineering, this much very much useful there. What the Lamis theorem says is that if the three forces P, Q, R are collinear, I mean passing through a single point, and if alpha, beta, gamma are the opposite angles for P, beta is the opposite angle for R, alpha is the opposite angle for Q, gamma is the opposite angle. Now this is true. That's what the Lamis theorem says. Okay, so P by sine beta equals Q by sine gamma equals R divided by sine alpha. I mean, the forces are proportional to the sine of the opposite angles. That's what we have to understand there. The forces are proportional to the sine of the opposite angle. That's what the Lamis theorem says. Okay, so let's prove that now. Okay, here I am drawing a picture like this. Take for example, this is what R, and this is what P, and this is what Q. Three forces are acting and they are collinear. Suppose this point I am taking as 0. The angle between this is I am taking as gamma, and the angle between these two I am taking as a beta. Now beta I am taking there. Then the angle between this I am taking as alpha. Now I am drawing a parallelogram. Okay, parallelogram I am drawing now. Look at this. You extend this and make a parallelogram like this. I am taking this point as B and this point as A. Okay, and this point as C. Okay, now what is this angle? Is nothing but what 180 minus gamma. 180 minus gamma, because this is 180, this is gamma, therefore this 180 minus gamma. Okay, now similarly here this angle is how much? 180 minus beta. This is beta and this is 180 minus beta. If this is 180 minus beta, this also 180 minus beta from the geometrical property. The geometrical property, this is a straight line, these are alternative angles, therefore 180 minus beta you will get. Okay, now this angle is this angle is 180 minus alpha. 180 minus alpha. Because this is alpha, you draw a straight line, it will be 190 minus alpha. This is a straight line. These two are parallel. Therefore, this angle must be equal to this angle. Right, very clear. Am I correct? Okay, now come to the consider the triangle OAB. Okay, so from OAB, from the triangle OAB, applying sine rule, I am applying there. Sine rule. Okay, sine rule gives, what it gives is that P divided by sine opposite angle, sine 180 minus 180 minus C. Here is the force. So opposite angle is 180 minus beta. Therefore 180 minus beta equals Q divided by, Q is the force. Where's the Q? Here's a Q. The opposite angle is 180 minus gamma. So Q divided by sine 180 minus gamma. Okay. Similarly, the last force R, take R this direction. R is proportional to the opposite angle, 180 minus alpha. So R divided by sine 180 minus alpha. Okay, now which implies, we know that sine 180 minus beta is beta. So P by sine beta, P by sine beta is equal to Q divided by sine gamma equals R divided by sine 180 minus alpha. Sorry, this is gamma. I make quiet. This is gamma. This is gamma. Here sine 180 minus alpha is sine alpha, and this and thus we can prove that when the three forces acting at a single point, then the forces are proportional to the sine of the opposite angles. That's what we prove here, and thus we can prove this. Okay, so that's proof. That's proved. Okay, thank you for listening so much for listening to this. Thank you. This implies this. Thank you.